Welcome to EPG Pathshala lecture series for postgraduate students in architecture. The paper we are discussing is Sustainable and Green Building Design, and the module we'll be delving into is Environmental Architecture and Climate Related Issues. In this lecture, we hope to learn to define environmental architecture, to comprehend the importance of energy efficiency, to understand the relevance of climate in sustainable design, to comprehend the essence of the geographic region and relevance of site to sustainable design. If you look at environmental architecture, we can start with an example over here. If you look at the George Cathy Dombrowski Center for Horticulture at Toronto, this is also a botanical garden, Montgomery Sisam Architects, Toronto, and this is a LEED Silver certified building. Over here you can see the building is built such a way that it is actually projecting from the site. It is well within the realms of the site, and the site and the building are in cohesion, where the building and the surrounding trees itself are actually bigger and taller than the building as such. The material, the color, the garden roof, everything is in cohesion to have a very sustainable as well as environmental friendly architecture. Design and construction industry is possibly the single largest contributor to Canada's solutions for compliance with the Kyoto Protocol for creating long-term ecological sustainability. So, environmental design is definitely an avenue towards sustainability. We need to make sure there is a potential for environmental leadership in architecture, and like how Canada has taken a step in this direction and other Western countries too have taken a step in this direction, it's high time countries like India and China also step in, because we are not too far behind when we think of the energy consumption our buildings are currently making. The 5 major principles of environmental architecture: healthy interior environment, energy efficiency, ecologically benign materials, environmental form, and good design. So, this is an example of another building, the Center for Cellular and Biomolecular Research, University of Toronto, Benish and Architects, Alliance Architects. So, here again, even though the building here is quite different from the previous example that we saw, this is a building that is soaring quite in height, which shows that having a glass facade building doesn't necessarily mean that it has to be sealed off. Here the openings are much more viable and openable. The building has a core in the center. It has certain materials that have been used that are benign to nature in the sense that can be reused or have a longer lifespan. And this building was considered a very suitable example for environmental architecture, because in Toronto the climate ranges from cold to very cold, and this building actually consumes a lot of less energy to keep the building warm. It is faced in such a way that it's able to use the solar energy it gains to warm up the building and make sure it's a suitable environment for work inside. If you look at a healthy interior environment, all possible measures are to be taken to ensure that materials as well as the building systems do not emit any kind of toxic substance or gas into the interior atmosphere. Additional measures are to be taken to clean and revitalize interior air with filtrations as well as plantings. So, here you have the Cambridge City Hall, designed by Diamond Schmidt Architects, again in Ontario, LEED Gold certified. Here again you can see how glass has been used in a positive environment. So, that's where we need to step in and see, as a developing country, what material is suitable for what climate and what typology of building as well. All typologies of buildings cannot be designed in the same way with the same materials. Certain typologies of buildings in certain places with certain kind of climate require certain types of design. So, climate, site and typology or the genre of building is very crucial to decide what kind of interiors is possible. Here you can see it's completely daylit, barring for the few lights here, but otherwise there is no artificial light. If at all there are artificial lights, they are supplementary artificial lights, again in days where it's very gloomy, or in the evening, or in the night times. So we need to ensure that all our fittings with respect to electricity consumption, lighting, as well as air conditioning or heating is not the only basis or the only substructure that is there for the building to survive. It can be an ancillary or tertiary source of power. All possible measures are to be taken to ensure that the building's use of energy is minimal. Cooling, heating and lighting systems are to use methods and products that are conserved or eliminate energy use. So if you look at energy efficiency over here, you have the Stratus Winery. This is in Niagara-on-the-Lake, Ontario. Les Andrew Architects. This again is a LEED Silver building. Here our winery has a particular purpose, a particular use. It has to have a certain kind of climate for the wines to cure in. It has to be stored in. So there are a lot of other purposes and assignations that are required. Despite that, the building is well sited on the site. It is not going to take back too much. It is not very high. It's not very tall. And similarly, if you look at our own example, we have solar air conditioning being used in Turbo Energy Limited in Chennai, where solar panels and the any kind of air conditioning that runs in the building is predominantly fired only by solar energy, which actually is a very good relationship, because greater the solar power, that means it's hotter the day, which means air conditioning is required. So if the solar power should be able to support the requirement for air conditioning, and the days the solar energy is not sufficient, it is a cloudy day or a gloomy day, or it's raining, then automatically the requirement for air conditioning also comes down. So they have a directly proportional relationship. Sunnier the day, the more requirement for air conditioning, and hence and vice versa. So when you actually look at this kind of relationship in a building that is happening here, all office buildings can adopt this method. Here again we have the CMHC Healthy House. This is by Martin Labour Architect, by Breathe Architects, Toronto in Ontario. And similarly, if you look at the IGP office in Gulbarga, which uses passive downtrot evaporative cooling, which is PDEC, where this system, air actually passes through a layer of water in a wind tower. So you basically have a wind tower, there's air that is forced through it because of the stack effect. That water is cooled, and that air that is cooled is let into the buildings. This is suitable in places where it's not very humid and it is dry and hot. When it's humid, this might not be suitable because water vapor will increase to the humidity of the place and the microclimate will drastically change. So you can actually see how we can use the natural elements that are prevalent around and in the site to change the climate and comfort zone of that particular building. Now we'll move on to ecologically benign materials. All possible measures are to be taken to use building materials and products that minimize destruction of the global environment. Wood is to be selected based on non-destructive forestry practices. In the sense, it could be salvaged wood, wood from older sites, wood that has been discarded, and other materials and products are to be considered based on toxic waste output of the surrounding areas. So it has to be benign in the sense we should not be destructing the environment or disrupting the environment to procure that material. And another thing we need to take care over here is the proximity of the availability of that material to the site. Importing materials from across the world is not considered an ecologically good solution because of fuel that will be consumed in airways or ships or whatever mode of transportation. So there is a particular radius around the site that we should maintain and procure materials within that radius and reduce the carbon footprint of that building right at the stage of construction. Here again you have an example of the Mountain Equipment Co-op in Winnipeg Prairie Architects. This is in Winnipeg. Here again you can see how a particular, this is actually a brand. The Mountain Equipment Co-op is a brand. They have particular sporting gear and all of that. So the glass facade to a certain extent is required for sales and advertising purpose, but the storage and the shop as such, they have used it for branding in a different way. Here again, if you look at materials being used, Grundfos pumps in Chennai, here you have thermal storage where the materials are such that they absorb thermal energy or solar energy throughout the day and they gradually release it in the evenings, and that energy is actually converted to electricity to power the lights and other facilities around. Here you have the Jackson Triggs Winery, Niagara-on-the-Lake, Ontario. This is by KPMB Architects, and this is the RMZ Eco Space in Kolkata. If you actually look at both the places, the climate is vastly different, but in terms of building materials, they are quite similar because they have taken certain elements of the building which can be utilized. Glass has not been completely removed because now a lot of technological advancements have happened in glass where you have double glazing, triple glazing and all of that, where daylighting is there, but it insulates the building or prevents the heat from entering the building. It acts like a filtration device. By not having too much of glass, what happens is daylighting becomes a big problem. So glass is crucial because glass lets in a lot of light in to come, and especially in a place like this, which is like a factory where light is essential. And again, this is also a techno park where light is essential. Light cannot be ignored, but let's not bring in heat. We need to decide and segregate that daylight and sunlight are not the same. Sunlight is with heat, but if we actually filter it and bring it through a number of protection devices, daylight is the best way to light any kind of building. Moving on to environmental form, all possible measures are to be taken to relate the form and the plan of the design of the building to the site, the region as well as the climate. That is the A of architecture. We need to make sure that our form and plan and the site, the region and the climate all go hand in hand. And that is one of the primary reasons we cannot blindly ape architects from the West. A building that is suitable, say in Canada, in New York or San Francisco, needn't be necessarily suitable for a building in Shanghai or in India for that matter. Measures are to be taken to heal and augment the ecology of the site. It is sometimes not possible to have a site or build on it without removing trees or cutting down trees. But what can be done to limit the after effects of that is to landscape and replace those trees immediately in another place, so the carbon footprint, or actually even put in more trees for that matter, so we do not take as much, we are giving back as much as we are taking from the environment. Measures are to be taken to relate to the form of the building such that it has a harmonious relationship between the inhabitants and nature. It's very important that we do not segregate nature from the inhabitants. The building should act like a transient space between the inhabitants and the nature rather than being a barrier. If a building becomes a barrier, that's when the problem arises. A building should be a transitional space, a place of communication between the people, the users, and the elements of nature outside. That does not mean that they are not going to get protected, and that does not mean having open spaces or courtyards. Even a completely enclosed space, like for this example over here, you have the YMCA Environmental Learning Center. This is in Ontario again. You can see how the site and the building are in correlation. From a distance, the building will actually just look like an inundation of the site. Let it be the material, the color, or even the shape of the site, the plan, the elevation, all of that is in relation to the surroundings, the quality of the site and the climate. Moving on to good design, all possible measures are to be taken to achieve an efficient, long-lasting and elegant relationship of use areas, circulation, building form, mechanical systems and construction technology. Here we have the Glen Eagle Recreation Center in Vancouver. Even within a country like Canada, between Ontario, let it be Winnipeg, Vancouver, the climate drastically changes. Similarly, like how you compare it to a country like India, where you have Gulbarga, Delhi, Chennai, Bombay, Calcutta, all of these places have different microclimates. To be honest, Bombay, Chennai and Calcutta will be similar because they are coastal cities with hot and humid climates. But if you compare it to places like Bhopal, which is in Madhya Pradesh in the center, or to say Himachal Pradesh, Gulbarga or Delhi, the climate varies drastically. So we need to take into account that our design, the climate go hand in hand. It has to have an efficient design. It doesn't have to just be different for the purpose of being different. Yes, the design, there's a lot of pressure on architects to produce newer, better designs. But what we forget in the longer run is having sharp angles, having glass and steel does not make your design different. You can have glass, you can have sharp angles, but does your site warrant the use of such materials and such design principles is what we need to ask ourselves. So let it be the building form, let it be the mechanical systems, or what kind of materials or construction technology we are going to use. It has to have a correlationship to the inhabitants, to the climate and to the region. Symbolic relationships with appropriate history. The earth and spiritual principles are to be searched for as well as expressed. Finished buildings should be well built, easy to use and aesthetic as well. That goes without saying. A sustainable building has to have all the factors that a normal building has, and that is what we need to change our mindset to. Now sustainable building has become a genre or a fad which has to slowly gradually change, and any building that is henceforth built has to be sustainable. Rather than saying that a sustainable building should also be aesthetic, let's say that all buildings should be sustainable, easy to use, well built and aesthetic as well. So that needs to become a requirement, a basic requirement of any building built by a good architect. Here you have the White Rock Operations Center at White Rock. This was designed by Busby Associates, which is certified a LEED Gold. So if you look at these certifications and these buildings, some of them might be like, if you look at this as a design, this may be, it's just a box. But if you actually look at it closely, not like a layman, you can see the change and textures and materials. You can see the overhang that has been given. You can see the overhang that has been given over here, which acts as a natural shading device. You can see a kind of basement which has been provided. You can see just from one angle of the site and the photograph, we can see the importance that has been given to the various elements of design and the relationship to the site. What exactly is an ecological footprint? It is basically a measure of our consumption or emissions as a result of our lifestyle. So basically the bottom line is smaller is definitely better. So let's try reusing our spaces, redefining our spaces, creating multi-purpose spaces. That's the new keyword now. We can have a library which is also a multi-purpose hall. We can have a multi-purpose hall which is an auditorium. So we need to assign more utilities to one space rather than having different spaces for different utilities for different times of the day. So our design program, our site, our inhabitants, our users, our climate, all of them have to be taken into consideration rather than having an agenda to create a posh new design. What exactly is sustainable design with respect to climate related issues? If you look at the correlation between buildings and climate, there has always been a very close relationship which has been got lost only in the recent past with the concept of modern architecture coming into being. Let it be right from the olden days, even let it be, let's talk of the buildings or the dwellings during the caveman period. Whatever was required at that point of time in that climate, only those kinds of dwellings were constructed. Even in history, if you look at it, let it be in India, we have our historical forts. If you compare even within North and South India, if you look at Fatehpur Sikri and compare it to the buildings in Srirangam and Madurai, you can see there's a drastic difference in materials because the weather is drastically different. Even in those days when climate played such a crucial role, and I think the main reason that happened was we did not have any mechanical services. There was no electricity, there was no fan, there was no air conditioning, there was only the natural daylight, wind, and the lanterns that they would bring in the evenings. So they had to only think about how to bring all these elements in and make sure that they were protected from the natural elements like wind, fire, rain, storms, and all of that. But now, as technological advancements have happened, we have created problems, and now we are trying to find solutions for those problems. First came the elevator. We decided, okay, now we have an elevator, let's build high. But the elevator is consuming power, we forget. And as we are building higher, we need to shut the windows because wind is blowing at a greater velocity. Once we shut the windows, there is no ventilation, we need a fan and an air conditioner. And once we shut the windows and we make sure that there are offices all around, there is no light. Then we need to have light fixtures. So what has happened currently is modern architecture, while giving us great solutions, has also given us a huge backlog of problems. So if you actually look at the buildings now we have just described, they account for nearly 40 to 70% of energy use in America. And this cannot be sustained given the climate change that we are undergoing with the greenhouse emission gases, fossil fuel shortages. So this has to drastically drop or change. This lesson will help us examine how to reconnect the issues of local climate to building design. If you look at the weather of the world, it varies basically by location and relates to the distance from the equator and is differentiated by aspects like trade winds, whether it's close to an ocean, sea, elevation from sea level. All of these are factors that decide the climate of a place. The Earth's atmosphere helps to moderate the climate to prevent radical shifts in temperature from season to season and day to night. So we have a general perception that around the equator we have an equatorial region, then we have a tropical region, then we have the polar Arctic region. So we have temperate, we have divided ourselves based on our climate. We know the different climates that exist. And for most extent, most geographical areas have a similar kind of climate, unless of course there's an anomaly, especially with respect to elevation. For instance, if you look at Ooty and Coimbatore, for instance, the climate in Ooty and Coimbatore is drastically different even though there's hardly any distance because of the elevation above sea level. Similarly, if you look at Chennai being along the coast and say a city which is inside the coast, again there is a drastic change within the elements. So there are basic certain situations that we need to cater to in this scenario. The impact of the sun on our buildings is a direct result of our distance from the equator. This affects the amount of solar radiation as well as solar geometry. If you look at any old building, right, let it be in the time of Michelangelo, Vesuvius, whoever, they always had a solar pattern, a solar geometry in place, because only with the direction of the sun did they decide where the openings are going to come, door is going to come, where the window is going to come. But now what has happened, we have a software for everything. We just put in the data and we are not even sure whether the building that can be built in Singapore, is it suitable to be built in Chennai, or is the building that is built in Chennai suitable to be built in Jakarta. So we need to actually analyze these places as places by themselves rather than in the larger scenario. Moving on to a sustainable ethic behind sustainability. What exactly defines it and what ethics need to be followed by architects? It's not a style of a building, it has to be a way of thinking now onwards. There are architects who call themselves sustainable architects, and that is something we need to gradually change, because all architects should become sustainable architects. If you call yourself an architect who does not believe in sustainability, it really does not make sense, because as an architect it's our duty, and we are duty bound that our designs are sustainable, are in context to the site and the climate and the people who are going to use it. We need to make sure our design, the way we construct and operate the buildings, are all in cohesion. Our primary goal is to lessen the harm that poorly designed buildings do and make sure we learn from ancient building approaches. We need to make sure green buildings take less from the earth and give more to the people. Now, if you look at an environmental moderator, A building's primary function is to provide shelter from the elements as a function of climate. So it should be a transient space. It is placed we need, which is covered. We do not get wet in the rain. We do not get too much sun. We are not covered by snow. All of those elements are there. But the building should be in growth from the site rather than something that is brought and plonked on. So if you look at the example over here, we have the Urban Ecology Center in Milwaukee. Here you can clearly see the materials that are used, which are natural. They are salvaged. They are from a site that has been demolished. So all of this we need to take into factor. So the building has to be a moderating factor between the climate and the site and the inhabitants and the users. To function as a moderator of the environment and to satisfy all other requirements, a building envelope must provide a control of heat flow, air flow, movement of water as vapor as well as liquid, solar and other radiations as well. If you look at building envelopes, they are basically like balloons. Modern building envelopes are like balloons. They are basically very thin, but their performance is therefore even more critical. This is the Rose Planetarium within New York City, where you might think, what is this structure going to do? But the structure actually enables people to understand the planetarium as it is, because most of our planetariums we don't even realize how the structure is, how is it as a globe. Here the planetarium is made as a part of the solar system and it actually has a role to play. So a proper justification is required for such a design to happen. Technique versus technology. We have a traditional building over here, building sciences, where the windows and glass are still very pertinent because that is the way daylight gets in. And every level that you see in this cathedral or any kind of towering structure, the mass of the building and the size, the percentage of fenestration to the building was in coherence to the climate that was there. Currently, if you see, we have huger and larger openings of glass. So besides permitting a lot of daylight, it does bring in a lot of sunlight as well. So old stone buildings actually relied on their massive nature to withstand the weather. But newer buildings have thinner layers and they are individually less able to withstand the elements, and therefore that's why we have an expiry date on most of our buildings. Because this is what we were discussing even initially. We have actually come up with problems and now we are trying so hard to find the solutions for those problems. If you look at high performance buildings, these buildings also have thin skins, but people expect a lot more performance from such buildings as they are technological symbols, cultural icons. Shelter is not the only purpose of such buildings. So now that's what we were talking about. Buildings are no longer just user friendly. They have become a part of the cool factor of a city. They have become that boasting factor. They have become like, oh, I have the tallest tower in my town. I have the tallest tower in my city. So every country is competing hard every year to add on floor after floor. But at the same time, they have to be high performance buildings, because if users are not able to utilize the building, it's nothing but a metal tower. Moving on to bioclimatic design. If you look at our country, we have a particular set of regions and the set of climates within that. We have cold up north, Jammu, Kashmir, Delhi, Himachal Pradesh. We have hot and dry in the west in Gujarat, Rajasthan. Monsoonal along the western Ghats right from Goa, Karnataka, Kerala. Then on the east we have warm and humid Tamil Nadu, Andhra Pradesh, Telangana and West Bengal. Then we have the composite, which is in the northeastern part of the country, which is a combination of both cold, monsoonal as well as warm and humid, hot and humid. So these are the basic climate zones that we need to be thinking about. If you look at world climate zones, you have all based on the equator. Along the equator, we have equatorial climate, then we have tropical climate, and then we have the Arctic Circle. So we have both a combination of equatorial as well as tropical climate, because even though we are close to the equator, we have the Tropic of Cancer running right through us. So if you look at the cold climate cathedrals, So what did a cold climate, how did the olden days techniques delve into it? You had the buttressing systems in stone which actually allowed, if you look at a buttressing system, this is what is a buttress. So anything that supported the building but also gave it that massive size which made sure that the building would be stable, will also be able to hold up the windows and glass facades because that's what let in the light. So they were actually hindered by limitations of wall because they had to give in more light and heat the interior cold and draughty cathedrals. So the buttressing system actually allowed for having the windows as well as giving the massivity to the structure that was required for stability. Hot climate cathedrals, like the Gothic cathedrals in the hot climates, did not require the buttressing system because glazing was not as apparent as required. They had the simple clear story windows and the window area was much lesser such that the heat would not enter the building but only daylight would enter the building. Now if you move on to traditional hot climate design, in hot arid climates, windows are kept to a minimum to prevent sun from entering the building. Bright stucco finishes are used to reflect light and keep the environment bright as well. Courtyards. Courtyards are used in hot arid climates and they work well because sun can warm these spaces in the cooler months. Courtyards do not work in cold climates because of the low winter angles. It will make the place cooler and colder in winter. If you actually look at courtyard buildings, courtyards have multitude of purposes. Let it be in warm climates or warm and humid climates like even Tamil Nadu, as well as Karaikudi, and those places also have courtyards. So we'll be looking at courtyards in a multitude of fashions in the following few presentations as well. So that brings us to the end of this module. Thank you.